Hello everyone. So welcome to this video. So in this video, we gonna focus on a very special homework. So I think this homework very interesting for newcomer because it introduces a real situation in that we need to use stack for solving specific problem. So this problem its name is street parade. So it means that in this video, sorry. So it means that in this problem, it's similar to its name. Yeah, its name told everything about the problem. So in this problem, you have a car. So very special car. We call this mobile. So it's actually a car. So you need to rent a car, the cost for parade. So for example, here you have a liable cost, a mobile. So they have each car, each have a very special number. So you want to parade this liable car. So you want the car had the smallest number will be go out first, and then next the second biggest number. So it means that you want to keep the order for the car will be go out for parade. So for example, here you want the car with the number 1 go to first, next the second, and then number 3, next number 4 and 5. So number 5 is last one, even though it's the first car, but it will be the last one come out. Okay, but the street is very small, so we cannot arrange two cars as simultaneously. So it's just we only can have a one by one go out. So to resolve the problem, we have another street here. So very small one, still small one. So if this car is not suitable for parade, we will move the car into the street here, the side street here. So here, for example, here, number 5, go to here. If the number 5 move to here, so the next car, we will check the next car. If the next car is good, in good situation, in good case, so because it's number 1, so it can go out. Yeah. So we move the number 1 go out for our purpose. So next the number 2, yeah, and then number 4, but number 4 is not good case because the number should be right after the number 2 is number 3. So we move the number 4 to side street, and then number 3 will be go out, and then next number 4 and 5. So this is a good case. So they just provide you one example. Yeah, and this is a good case. But in programming language, in programming thinking, if you want to understand the problem better, you should think about multiple case. So if they provide you a good case, you should think about the bad case. So what is the not good case? So what is the case in that the output will be no, not yes anymore. So yeah. So if you can parade the car in right order, so you say yes. So I hope that you already read the problem description here. So if you cannot parade the cars in order, you cannot do that. So it means that you need the sample output will be no. So we should think about a case in that you cannot do the purple. So it means that you should think a case in that the output will be no. Yeah. Okay, so let's think about a case in that. One more thing before we move on. That you see that this is side street. So if you look at carefully, you can easily to get that the side street it works similar to a stack. So why is it? Because you see that number 5, it's going the side street first, but it will be the last one come out here. And number four is the last one come to side street, but it's the first one come out. So it means that's the last in, first out. So it means it is stuck. Okay, so we move to here. So we should in a case in that we should output in no. Okay, so because the side street is the is stuck, so last in first out. So if the car with number 5 not here but is in here, so it means that the case with number 4 and 5 they exchange, they swap to each other. So what problem? How can we solve that? Okay, I hope you have a situation. I hope you have a solution for yourself. So let's try to resolve the problem. So here we want that we have a car with number 5, 1, 2, 4, 3. Okay, 5, 1, 2, 4, 3, and the output, as you know, it will be yes. So we want to have a case in that the output will be no. So we want to swap, exchange number 5 and number 4 for each other. So it will be 4, 1, 2, 5, and 3. So you see that. So it means that because this one, you see that because this is the first input come to you. So in right case in because it's the first input come to you, so it will be the first car. So we got here. So we get here 4. So this is your street. So it's 4, 4, 1, 2, 5, and 3. Yeah. So we have a street here. Street side here. Okay. So number 4 is not a right number for brain yet. So we move for here. So we delete here. So 4 is not here anymore. So we be go out, and we don't have a 1 anymore. So number 2. So number 2 is a good one. So we move out. So we don't have number 2 anymore. And next, number 5 is not a good one because we want number 3. So we move 5 here. So we don't have a 5 here. And next, we want number 3. Yeah, that's it. Sorry, number 3. Yeah. So finally, we have a remain number 5 and number 4. But you see that it is stuck. It is stuck. It's a last in, first out. So you see that. So if number 5 come out, so it means that the cars will be come out in the wrong order. So it's not a good case, it's a bad case. So it means that the output will be no. Because it is stuck, we cannot move number 4 go out. Because number 5 is it stand in front of number 4, so number 5 cannot go out before number 5 go out. So we don't have we have no choice here. So you see the output will be no. Yeah, so that's the best case. We usually we call that in the normal case. So this is would be yes and this is no. Yeah. Okay. So, but how can we solve this kind of problem? So you see here, we need output here. We need street here. One more street. And so we have 5. I'm sorry, I forgot the number. 5, 1, 2, 2 and 4, 3, 4 and 3. Okay. As you see that when you see the number 5, you know that it's not a good case. It's not a good number for go out, because we want number 5 go first. So you can imagine that there are someone here. Oh, I'm sorry. There's someone, some people, some person stand here and have a counter. So he will start counting. So at the first time, at the t time 0. So this means that we start here time 0. So time 0. The counter equal to 1. So if the car number and the counter have the same value, so the car can go out. So it's a good number for go out. So if a car number and the counter is not equal, so it means that the car cannot go out. It should be go to the side street. Yeah, you see that? So in this case, the number 5 and the counter don't have the same value. So it means that the number 5 should be go to side street here. Yeah. So we don't have a number 5 here. So next we see that number 1, the car with the number 1 have a same value to the counter. So number 1 will be go out. So down here. And after the car go out, the counter will be increasing to 1 value. So the counter will be equal to 2. So at the time t1, the counter will be equal to 2. So number 2 is good. It equal to the value of counter. So number 2 will go out. So we don't have a value of number 2 here. So next, number 4. So you see that the number 4 is not equal to the counter. So it should go to the side street here. And so we don't number 4 here. So number 3, after number 2 go out, we should increasing the value for the counter to number 3. So you see that now the number 3 and the counter have the same value. So number 3 can go out. That's it. So after the street empty, it's empty now because we don't have any car in the street here. So we should start to check the side street. Okay, so you see that after the car with number 3 go out, we increasing the counter to 1 value, so it equal to number 4. So you see that the car in the side street is equal to number 4, so it's good. We move it out. Okay, we don't have number 4 here. So T4, the counter equal to number 5. So number 5 should go out because it equal to the counter. So number 5 go out. And that's it. So the counter, if it goes sky, the counter will equal to value of the number of element. So you see that. So here number element is 5. So it's a good case. So it's a normal case. So let's go to the unnormal case. is a bad case. So we call that abnormal case. Okay. So 5, 1, 2, 4, 3. Okay. So we have a street, another street here. So we have 5, 1, 2, 4, 3. It's a good case. We want to exchange number 5, number 4. So sorry. So it will be number 5. It will be number 4. So same in the reverse one. We have a counter here. Here a counter. So number 4. Number 4 the counter will be equal to 1 now. So I will to make more clear. I will say it as T0 the counter equal to 4. Equal to 1. So number 4, the value is not equal to 1. So we cannot move the number 4 out. So it should go to the side street here. So we don't have a number 4 here. So it should have a number 1. It's equal to the counter. Yeah, it's okay. Move it out. Okay. And we increase the counter to number 2. Number 2. That's it. So sorry, we don't have a number 1 here. So it's number 2 is equal to the counter. Okay, good. Okay, move out. So number 2. So after we move the number 2 out, we need to increase in the counter with one value, so equal to 3. Okay. So number 5 here. Number 5 here. So we cannot move it out. So it should go to side street here. Okay. And number 3 is equal to the counter. Okay, good case. Move it out. Okay, that's it. So after we done the street empty here, so it's empty now. We need to check the side street here. Okay, but you see that we cannot move the side street because it's not equal to the counter. So number 5 not equal to the counter here. So it means that we have to stop here. We cannot continue the program anymore because the value of the top of the stack is not equal to the counter value at the T0. Okay, so number 5 cannot go out. So we see that the counter is not equal to the number of 11. So it means that we have to say no. So you see that. It's the very simple thinking to how to resolve problem. We just follow exactly what the problem description told you. Okay, so if you want to solve a little bit difficult problem, you need to know how to solve it manually by your hands. So you see that we have a counter here. So we have a idea using a counter. So if a counter after you do on the car, go out and check. After you check on the car, if a counter and the number of 11 have the same value, it means that the output will be yes, and if not, otherwise it will be no. Okay, so it's a very easy one. So but in this problem you have another smaller problem. You need to take care that the case in the input there are several test case. Mean that they do not come you with just one test case. They come to you with multiple test case. So if the number, so the first line will be is test case will be the single number n. So if n equal to 0, it means you see that here, it means that you should stop the program, the input n with number 0. So number 0, it means that we don't have any test case more. So we can stop the program here. And if the number n is not not 0. So it means that they will come to the second line. So the second line come to you that contain the number 1 to n. So it's a binary order. It means that they do not have an order. So they do not have an increasing order or decreasing order. So they a binary number. So you need to handle that. For example, here it's not the increasing order or increasing order or decreasing order. Okay, so you need to face with this challenge. So but it's not that difficult, it's very easy. So okay, so let's move to coding. How we can we code it. Actually, if you solve by yourself, you should not start to coding here. You should have a simple idea, the idea in more detail before you move to coding. You see that? I usually have a try to write out something, for example here. So I think about a counter, and I think about the side street is stuck. So it means that we have stuck here, and I have a counter number. It's equal to 0 and stuck will be empty the first time. Okay, so I have a street here, so I contain the value inside the street. So it will be 5, 1, 2, 3 and 4. I assume that I assume I have that. Okay, so I need to check. So I think that if a counter and the car value have equal, so it means that the car can move out. If not, we should try to move the car to side street. So it means that we have a code if street init. Okay, so equal to the counter. So we do what? We increasing the counter to 1. It means that the car move out. So otherwise, so it means else. So it means not equal. So we do what? We move to side street here. So we have a stuck here. Append what? Append the street init. Okay. So yeah, it's very simple thinking, very straightforward thinking. So after we done the job with the street, we move to the stock. So we see that if the stock, the last element of stock equal to the counter, so we what we need to do, we continue to increase in the counter value. So and then we try to pop. This means that we remove number out of stock. Okay, so if it not equal, so what happened if it not otherwise? If it not equal, so we do what? We stop here. We can't do anything more. We need to stop here. Yeah. So after that we compare. If the counter equal to n it means the number of element. So n in the number of element. So it's just pseudocode, so you don't need to care about the syntax error. So we just write down the idea. Okay, if equal to number n, so we say yes, and otherwise we say no. Yeah. So yeah, it's very straightforward idea. Okay, so we go back to coding. So how we can implement those ideas into coding? So it's very easy, so not difficult. Okay, so first we have a side street, so it means that we have a stuck here. we need to have a side street. Okay, so usually I have usually we have description here. What we need to do here, you can write down your algorithm here. Algorithm. So if you move the code to your friend or your teammate, they just look at this one description to understand what you have done in your code. So they don't, your friend don't need to look at the code in detail to understand what you have done. They can look at the test here, so to understand. So test is more easier to for reading, better than the code. Okay, so it can save your friend Tom. And maybe now when you start writing the code, you can fully understand the code, but maybe next 3 months you cannot remember what you have done here. So at that time you can read the description to understand what you did in the code in the reverse 3 months. So it's also saving your time. Okay, so try to write down your algorithm description here before you move on. Okay, so here for saving time in this video, I go straight forward to the coding. Okay, so we need a number n here. Okay, some number n here because you have to keep in mind that the program will be exit when number n equal to 0. So you can say that if y, so it means that the program continue working continuously when the number n is not 0. So you can say is when, so if it's not 0, so we continue to working, but it's not a good way to represent that idea. You can represent that idea in more way that's more easier for understand. So you can write while true. So I hope you still remember it's while true. It's loop forever. So you have input number n. So we have input here. Okay, so if number n equal to 0, so we do that, we stop the ID here. Okay, we stop the program. Sorry, we stop program, not the idea. So okay, so we have another statement called stuck clear. I will explain this about it later. So let's move on first. Okay, you will understand it later. Okay, so we need to handle the input number. You see that? The second line, all the number will be placed in the second line. So what does it mean? So it means that there are just one line contain all the number. So there and a line in Python input with string. So we need to handle the input. So we have a list map in input. So if you don't understand the whole statement here, don't worry, you will learn about it in the lecture 4. Okay, so we need a counter. So you can say we have a counter equal to 0. The first time is equal to 0, so we have an index for check every core number. Okay, the index of a core, so it's equal to 0 at the first time. Okay, so y index equal to n, we continue to check the core. So okay, so if so we before we do anything, we need to check the sidecar first. Okay, length. So if the side street, the core in the side street, so it's in stuck. So if stuck, it number element in the stuck in not 0, it means that we have a core in the stuck, and the stuck and the last element of stuck equal to counter plus 1. So we need to stuck to pop. It means that we remove the element of stuck. And if the street index equal to you can say equal or different in both case. So equal to counter minus counter plus 1. So we in not equal, it means that we move the call into the side street into stuck. So we append the street in that. Okay, and otherwise you it means that the side street the car in the street have a value equal to the counter. So it means that we just increasing the counter. Okay, so the counter plus 1. And after we do all the things, we increasing the index. So it means that we move to the next element equal to 1. So that's it. After we done here, so we go here. Let more have a more space here. Okay, so after we check all the element inside the street, we need to check the remaining element in the side street in the stack. So we check all element in the stack. So if length stack not 0 and stack, the last element will be equal to the counter plus 1. So what we need to do, we increase in the counter. So and we remove call out of the side street stack. Okay, and the last code is very simple. If counter equal to n, so we do that, we ring yes, otherwise we say no. Yeah, that's it. That's all the thing we need to do. Let's check the value. So we try to run straight here. We input the number, first line number of element. So we have sorry, I forgot. So we can copy here. So it's a yes, it means good case. So for example, we swap we have another test case. So if we swap the number 5 and number 4, so the 4 1 2 5 3 here. So we say no. And when we input the number element equal to 0, it means that we end the program. Yeah. So we good. We start. We very good here. Okay. So after you done your code, try to use Git to maintain your source code. Try to Git add. So I remember you already watched my video about Git tutorial. So try to use Git here. Okay. So you can do commit solution for street parade problem. Okay. And the file name, that's it. And try to do git push. So you can check the code in the git branch letter 3. Yeah. So you can go to GitHub here. So you see that. Go to branch letter 3 and you will see the code. Yeah, here. Okay. I hope you feel comfortable with this problem. So if you cannot understand some idea in this video, feel free to send me email. I will tell you how to solve the problem. Or you can send me a Kakao message if you want. Okay. See you in the next video. See you later. Bye.